Good day, viewers. I am Teacher Roderick, and in this video, we will be discussing about factoring polynomials with common monomial factors. If you are new to my channel, kindly click the subscribe button and the notification bell near my name so that you will be updated automatically if a new video comes out and will not miss any of the videos I upload. So without further ado, let's get started. Before we start with our discussion, let us first get to know what is common monomial factor. When we say common monomial factoring, it is the process of writing polynomial as a product of two polynomials, one of which is a monomial that factors each term of the polynomial. We should also be familiarized with this one. Monomial. When we say monomial, it is an algebraic expression that has only one term. It can be a constant or a number. It can also be a variable or a letter with a non-negative integer power, or it can be the product of the constant and a variable with non-negative integer power. Examples of monomials are x, 9, 13x, y squared, negative 5b raised to 8. Factor. When we say factor, it is a number or algebraic expression that divides another number or expression evenly, that is, with no remainder. Let's take 25 for instance. What are the numbers that divide 25? 1, 5, and 25, these three numbers divide 25 evenly without yielding any remainder. Therefore, 1, 5, and 25 are the factors of 25. Let's have 2x squared. What are the numbers or expression that divides 2x squared evenly? They are 1, 2, x, x squared, 2x, and 2x squared. These numbers divide the given expression evenly. And when I say evenly, it will not yield any remainder. Therefore, these numbers are the factor of 2x squared. Distributive property. Distributive property is one of the most frequently used properties in mathematics. And by definition, distributive property lets you multiply a sum by multiplying each addend separately, and then add the products. Okay, I know that definition is not helpful for most people. It is easier for us to understand with an example. Let's take A times the quantity of B plus C for instance. According to our definition, when we distribute A to the addends and add the result, it will yield the same answer. Let's try. Distribute A to the first addend, which is B. A times B, the result is AB. Again, let's distribute A to the second addend, which is C. A times C, the result is AC. This is what we call the distributive property of equality. A times the quantity of B plus C is equal to AB plus AC. We have 4 steps in factoring polynomials by using its greatest common monomial factor. Step 1. Determine the number of terms. Step 2. Find the greatest common factor of the given terms. Step 3. Express each term as a product of their greatest common factor and the other factor. Step 4. Write the complete factored form. Problem number 1. Factor 2x cubed plus 6x squared. Let's first determine the number of terms. So how many terms do we have here? Okay, that's correct. We have 2 terms. They are 2x cubed and 6x squared. Now we are ready on our second step, which is finding the GCF or greatest common factor of the given terms. Let's first start with our first term, which is 2x cubed. What are the factors of 2x cubed? The factors are 2, x, and x, and x. Let's proceed on our second term, which is 6x squared. What are the factors of 6x squared? They are 2, 3, x, and x. Notice that in the example, prime factorization is used. Now, since we have the factors on both terms, what is common to them? Okay, that's correct. They are 2, x, and x. Since we know now the common to both terms, we can now identify what is the GCF. So the GCF of 2x cubed and 6x squared is 2x squared. Step 3. Express each term as a product of the greatest common factor and the other factor. We now have the result in our second step, and the GCF of 2x cubed and 6x squared is 2x squared. So, we are now ready to express each term as the product of their GCF and the other factor. Let's first start with our first term, which is 2x cubed, which is equal to our GCF, which is 2x squared, and multiply it to the remaining factor, which is x. So 2x cubed is equal to 2x squared times the quantity of x. Let's proceed on the second term, which is 6x squared. That is equal to the GCF, which is 2x squared, and the remaining factor, which is 3. Therefore, 6x squared is equal to 2x squared times 3. Step 4. Write the complete factored form. We have the result in our third step, which is 2x cubed is equal to 2x squared times x. 6x squared is equal to 2x squared times 3. With this, we are now ready to write 2x cubed plus 6x squared to their factored form. 2x cubed is equal to 2x squared times x. Now, let's copy the operation, which is plus. And 6x squared is equal to 2x squared times 3. Since this term have the same 2x squared, let's copy it, 2x squared. Now, put the numbers or expression in a parenthesis, the remaining numbers or expression, I mean. So, the remaining in our first term, the remaining expression is x, then copy the operation. The remaining number or expression in the second term is 3, so copy it. Now, we have the factored form, 2x squared times the quantity of x plus 3. Therefore, this is now the factored form of 2x cubed plus 6x squared. Let us verify if the result is correct. If the factored form of 2x cubed plus 6x squared is really 2x squared times the quantity of x plus 3. But how are we going to do it? Note, when you factor, see to it that the product of these factors is always the original expression or polynomial. So, we are going to use the distributive property. Now let's distribute 2x squared to the addends. So 2x squared times x, the result is 2x cubed. Copy the operation which is plus, and 2x squared times 3, the result is 6x squared. Since the product or the result when we distribute 2x squared to the addends is the same with our original expression or polynomial, therefore we can conclude that the result is really correct. Now let's have problem number 2. Factor 5y less 10y. First step, determine the number of terms. So how many terms do we have here? We have 2 terms. What are these terms? They are 5y squared and 10y. Now let's proceed on our second step, which is find the greatest common factor of the given term. So let's first proceed on the first term, which is 5y squared. What are the factors of 5y squared? They are 5y and y. Let's proceed on our second term, which is 10y. What are the factors of 10y? They are 2, 5, and y. Now, what is common to these factors? Okay, that's correct. The common to these factors are 5 and y. Therefore, the greatest common factor of 5y squared and 10y is 5y. Step 3. Express each term as a product of their greatest common factor and the other factor. We now have the result in our step 2, and the GCF is 5y. Now we are ready to write each term as a product of the greatest common factor and the other factor. Let's have first 5y squared. So when we write this one as a product of their GCF and the other factor, we write the GCF, which is 5y, and then multiply it by the remaining factor, which is y. So 5y squared is equal to 5y times y. Now let's proceed on our second term, which is 10y. Write it as the product of their GCF and the other factor. The GCF is 5y, and the remaining factor is 2. Therefore, 10y is equal to 5y times 2. Step 4. Write the complete factored form. Since we have the result in our step 3, which is 5y squared is equal to 5y times y, and 10y is equal to 5y times 2. We are now ready to write 5y squared less 10y to its factored form. The factored form of 5y squared is 5y times y, and the factored form of 10y is 5y times 2. As you have noticed, these terms now have common, which is 5y. Let's copy it and write the remaining expression inside the parentheses. The remaining expression in the first term is y, copy the operation minus, and the remaining expression on the second term is 2. Let's copy it. Therefore, The complete factored form of 5y squared less 10y is 5y times the quantity of y minus 2. Let's have problem number 3. 4x cubed y plus 2xy squared less 8xy. How many terms do we have here? That's correct. We have 3 terms. And they are 4x cubed y, 2xy squared, and 8xy. Now let's get the factor of these terms. Let's start with our first term. What are the factors of 4x cubed y? The factors are 2, 2, x, 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 and y. How about our second term, which is 2xy squared? The factors are 2, x, y, y. And how about our third term, which is 8xy? What are the factors? The factors are 2, 2, 2, x, y. Now, looking at the factors of these 3 terms, what is common to them? Okay, that's correct. They have in common is 2, x, and y. Therefore, the greatest common factor of 4x cubed y, 2xy squared, and 8xy is 2xy. Now, let's write the given problem or the given expression to its factored form. So, let's have the GCF, which is 2xy. On our first term, what is the remaining factor? The remaining factors are 2x squared. And then on our second term, what are the remaining factors? The remaining factors is y. How about on our third term? What are the remaining factors? The remaining factors are 2 and 2. That's why we have 4. So, therefore, the complete factored form of 4x cubed y plus 2xy squared less 8xy is 2xy times the quantity of 2x squared plus y less 4. Now let's try your understanding. Get a piece of paper and try to solve the given problem. 7p squared less 7p. I will give you 20 seconds to solve the given problem.
Get ready to the countdown.
Time's up. The correct answer is 7p times the quantity of p minus 1. Another one, 18xy plus 3y. I will again give you 20 seconds to answer this
Get
problem.
ready to the countdown.
Okay, time's up. The correct answer is 3y times the quantity of 6x plus 1. 15t cubed less 15t squared plus 20t. Another 20 seconds to solve the given problem.
Get ready to the countdown.
Okay, time's up. The correct answer is 5t times the quantity of 3t squared less 3t plus 4.